This is a solution for question 1 of homework 9. We are given by a stochastic process W of t with mean 0 and the autocorrelation alpha min of t1 comma t2, and we are given a new process y of t equal to w of t minus 1 for all t greater than equal to 1 and 0 for t less than 1. So we're asked to find the expected value of y of t, the autocorrelation of y, and whether y of t is White's stationary or not. So first let's find expected. So stochastic process is said to be White's stationary if its mean is constant and the autocorrelation is only a function of tau. Tau is the difference in the time. So first let's find the expected value of y of t. So expected value of y of t is the expected value of w of t minus 1. Since this is a linear operation, we separate the expected value. So expected value of w of t is 0, which is given, and the expected value of w of t minus 1 is also 0 because the expected value is the ensemble average and not the time average. Therefore it is same for both the cases. So expected value of y of t is 0, a constant. Now the autocorrelation function of y of t, so ry of t1 comma t2 equal to expected value of y of t1 times y of t2. So substituting the function y of t1 and y of t2, we get this, taking the products. So we get expected value of w of t1 times w of t2 plus w of t1 minus 1 times w of t2 minus 1 minus w of t1 times w of t2 minus 1 minus w of t2 times w of t1 minus 1. So once again this linear operation, so we separate them. So this looks like the autocorrelation function of w of t. So we already know the autocorrelation function of w of t, which is t1 minus rw of t1 t2 equal to alpha times the minimum of t1 comma t2. So substituting that in the autocorrelation function of y, we get alpha times min of t1 comma t2 plus alpha times min of t1 minus 1 comma t2 minus 1 minus alpha min of t1 comma t2 minus 1 minus alpha times min of t1 minus 1 comma t2. So we have two cases over here. One is when t1 is greater than t2 and t1 is greater than t2 minus 1. So in this case, the first case, so the autocorrelation function of y becomes, so t1 is greater than t2 and t1 is greater than t2 minus 1. Therefore the alpha times min of t1 t2 is alpha times t2. Alpha min of t1 minus 1 comma t2 minus 1 is alpha times t2 minus 1 minus alpha times min of t1 comma t2 minus 1 is alpha times t2 minus 1 and alpha times min of t1 minus 1 comma t2 equal to alpha t2. So cancelling out the terms, we get a 0. So in this first case, the autocorrelation function is a constant, it is 0. In the second case, where t1 is greater than t2 but t1 is less than t2 minus 1, t1 is greater than t2 and t2 is greater than t1 minus 1. So if we consider this, so t1 is between t2 and t2 minus 1. So in this case we get min of t1 t2 is t2 and min of t1 minus 1 times t2 minus 1 is t2 minus 1 and min of t1 comma t2 minus 1 is t2 minus 1 and min of t1 minus 1 comma t2 is t1 minus 1. So substituting that, we cancel out alpha times t2 minus 1 and we end up with an alpha times t2 minus t1 plus 1, taking t2 minus t1 as tau we get the autocorrelation function of y as ry of t1 t2 equal to alpha times tau plus 1. So summarizing the autocorrelation function for both the cases. So we got the expected value and the correlation function, and the expected value was a constant, and the autocorrelation function is in the first case it's a constant, and second case it is a function of tau. Therefore y of t is a Whitson stationary process.